The first time I heard about the long polling back-end design pattern, whatever you want to call it, is back in 2018 when I started researching Apache Kafka. You see, long polling is such a beautiful pattern. That is, you can turn almost any request response into a long polled request response system. But what does it mean? What is it? Why are we so fascinated about this thing? This is what I'm going to explore in this episode of the Backend Engineering Disney. So first, let's actually define what polling is in computing really is. See, for most of you, if you are a native speaker, you don't have this problem. But us foreigners, we couldn't tell the difference between pulling and polling with a U versus with a O. You know, for the longest time I thought it's the same, but it's not. There's no thing as pulling in computer science. That doesn't exist. You know, maybe someone invented it, but we poll something, i.e. we check if the information that we're about to ask about, is it there or not? You check for notification. You call an API and say, is there some data there? Is there a message for me? You know, is there a video uploaded for this particular creator? You check, and you check because you don't know if it's there or not. And the purpose of making this request is to check. And if it's there, give it to me. If it's not, then tell me that it's not there. And that is where polling become a problem. How often do we check? Every second? Every 30 milliseconds? How often? Every minute? Check too late and you might miss a lot of videos, you know, or a lot of notification of messages. To check too often, and what do you have? You have a chatty, stinking system. Very chatty. Right? Because there are a lot of networking going on. There's a lot of these small bytes that are being transferred, carrying nothing. Sending requests and coming back with empty responses, because most of the time they are empty because there are no messages. So that's a problem of what we call short polling. You might say, what's really the problem with frequently sending requests to check if there is something or not? Like, send it every second. That's the problem. You only thinking about one client, you know, deploy it to 1 million machines, phones, apps, fridges, ovens, you know, IoT devices, all of them making a request every second. That eventually just tanks your backend, you know? And we backend engineers, we don't like chattiness. We are straight to the point. Give it to me straight. Just don't go on back. Stop chatting. Why are you doing this? Going back and forth. No. Come back. I'll tell you if there is something. This is where the pretty long polling come into the picture. And we see it clearly in and I'm not gonna mention push here because it's a very interesting pattern as well. But it has its own beauty, push, right? Maybe we should, but I don't want to contaminate this topic with push. Push is its own thing. It deserves its own video. Let's just focus on polling right now. So what did we say? We said, well, here's the thing. Let's go back to the definition of polling. What is it? Send a request, because everything is a request response, really. Everything. It's just a request and response. Right? And if I send a request and you want to check if something is there, if it's there, i.e., whatever I do, I query the database, I check my cache, right? And then I see that it's there, I respond with the content of that message, right? Maybe give me the latest 10 messages, or give me the recent messages, whatever it is. Give me the last visited or viewed messages or not viewed, unread messages, something like that, right? That's a common pattern, right? So then what you do is you respond with that. But then what if it's not there? There's nothing. You read every message. You don't have any unread messages. No? It's impossible to do this today in an infinite timeline, because there is always something. They will find something for you. But assume like DMs, direct messages. Hey, refresh. Do you have any direct message? Do you have it? No. If there isn't any, how about the back end doesn't actually write anything to the socket, to that connection socket? Just pretends that it's building the response. That's what log polling is, right? It just waits a little bit. Because in that waiting, the client is not actually blocked, because everything these days are asynchronous, right? You're sending that poll request, right? Poll with an O, not pull request, right? And now there is a poll. How about that? Poll request. All right, that was wrong. So you poll something, and then you just move on with your life. And if you're using Node or JavaScript, you're just in the event menu. You're doing an event model, so you're doing your own thing. That waiting, you're not actually waiting blocked, right? So the backend just waits and not actually responds back to that connection with that response of empty message, but it will actually just baby at any second that a new message will come, right? And if it's a very live system, hot system, that message might come if you, let's say, long polled for a second, 2 seconds, 5 seconds, a minute. And it's not a problem, because meanwhile, you don't really have anything going on in that pipe, you know? Yeah, there are TCP keep alive messages just to keep the connection alive, you know? But you sent the request, and technically the HTTP model says if you send a request, you have to send a response at some point, right? That's the request. That's an HTTP level layer 7 semantic, which you have to be careful with. Middle boxes, layer 7 TLS terminating proxies might have these timeouts in place. And I had a whole video talking about the beauty of timeouts. It's just everywhere, you know? So you got to watch out for that. How long to wait is an interesting thing. You cannot wait forever. You can, if you own all these boxes in the middle, and you own the backend, and you own the client, you can have a no timeout, essentially. So say, I built my system, I know what's going on, right? But you got to be careful for the middle boxes, because you don't own those too often, right? Especially if you have like an API gateway, you send a request. Most requests will say, hey, if I don't hear back in 60 seconds, I'm going to just give up waiting, right? But assume the timeout on the side. You will wait for a specific amount of time until you get something, and then you will write it to the socket. Okay? So in certain situations, you save a lot of chattiness. All these requests, instead of making let's say a minute, you made 60 requests from 10 clients, 600 requests. It's down to, 10, right? Requests. Way better than 600. And even you might not appreciate these small requests, but it adds up, in the back end of the resource management. Just like I gotta decrypt this request. I gotta receive it from the kernel, read it. I gotta decrypt it because it's encrypted with TLS. I gotta understand this protocol as HTTP. If it's HTTP2, there's a little bit extra more overhead with streams. Dealing with the headers, not actual HTTP headers, but the headers of the frame of HTTP2. There is more work. And we have to appreciate this stuff. It adds up. Every little thing adds up. So if you don't have to don't do it. So that's long polling. Long polling in this particular case is very useful because if I am as a client, I asked the backend to check if there are new messages, new chat, new logs, new whatever, right? And it tells me that, well, there is nothing, but let me block you for a second. And when this information comes, it can write back to the client and says, hey, here it is. The good thing about this is it's probably better for the backend to cache that knowledge in its vicinity, such that if a similar client asks the same question, it can serve this data hot, as opposed to go back to the database and retrieve it, So if someone did receive this information, we can essentially serve multiple clients from that same knowledge. And this becomes very interesting later. Yeah. So you can have many long polled clients all fetching and waiting for the same similar information. You can just distribute that to everyone. Well, it's not really distributing, it's just writing that back to the client. Okay, so now I want to take this even further than that. Knowing that we can make any request response model into a long poll model by doing the following. You see, when you make a request that is not polling in nature, it has nothing to do with polling. So let's say we're sending a request that is non-trivial. It takes time, and an example is generate a summary report PDF. Out of this range from this date to this date, give me a generate report. You can send a synchronous. You can send a space synchronous, not asynchronous, a space synchronous request to your backend and synchronously query and actually do the processing, build all this, the data structures required, actually generates the PDF, write it to disk, ship it down the client's socket connection as a blob, or as a link, whatever, you decide to do it, and then write it back. And meanwhile, the client is actually waiting, right? So it's actually sending a request and it's just waiting for this request to happen. So what you might have multiple clients doing the same operation on your backend. Many clients sending all these reports, and they might have different parameters. They might have similar parameters, and that's where your API design comes into the picture. You on purposely you can build your UI such that it generates the same parameters so that you can cache, and we're gonna come to that. So you can send a request, and that backend will actively start doing the request, process it, and then send back the response. So what you can do is essentially send a request, but immediately respond back to the client with an ID of the job that has been created for the client. It says, hey, listen, I put your request in a queue for further processing. I did not process it immediately, but I'm going to process it later. Now, later could be in a second, could be in an hour. So here's an ID, a GUID. a UUID. Come back with me to check the status. And now, what did we do? We turned this synchronous request response into a long polled model, where now we're polling. Now to poll, you can just poll like the old times, the short polling method, or you can actually do a long polling, just like bing, and then you just stick in and wait, right? Let me say, what's the difference? What did you do right now? Well, what we did is, and instead of immediately executing the request, we added a queue. So we have a manageability on the back end. Now I have a queue and I have a pool of processors, as opposed to immediately always process the request the moment it arrives. You put it in a queue, and that queue is manageable, as certain number of units, and you can have like any number of units. And then you have processors that will pull from this queue, execute, and write the response back, and now you scaled your backend. So even if you have 1 million clients sending all these requests, they will just go as messages in a queue, and they will immediately okay, you can generate as much messages as you want. Doesn't really do much, right? But imagine 1 million clients actually made requests to generate these PDF files. You will DDoS your backend, right? So that's something to watch out for. So you added some sort of a rate limiter, if you will, but in a clever manner. Maybe it's not that clever, but I just like it. So now it's a very simple model. So you've seen it a lot, right? So you see the backend will pull up, process, start executing, and then write back the response. And now your clients will come back with their ideas like, oh, what's happened to this? What happened to this? What happened to this? And they will just stick in long poll, but their long polling is not really expensive, because we're not really doing anything. On the older model, if you send a request and you want to wait for that response, if your connection closed as a client, after you send the request, in the normal request response model, where the backend actively generates the response for you on that particular connection, the moment you die as a client, you just disappear. There is no way to get that response. The backend, depends how it's built, it will see that the connection has disappeared, and it will either be smart enough to say, oh, the connection has appeared, let me just quit this process, because there is no point generating this response if there is no client to receive it. In case if the connection is lost, the client has disappeared, there's no way to get that response back in the normal model. But with this long polled model, after we turn this request response into a scalable, predictable, if you will, back-end model, we also have resumability in this long response. And this is my favorite thing. Now, even if the client has disappeared, connection has died for anything, I don't know, the middle boxes decided to kill your connection because you didn't send keep alive message, or it was technically ignoring keep alive messages for any reason, and that just destroys your connection, just removes the knowledge of your connection existence, and then you're done. So you come back with a new connection. What you do in this log poll model, you just come back with this your ID, your unique identifier that the server gave you, and says, hey, is it back? And you just resumes a new long poll session. And if you were lucky and you came back, the server will say, oh, here, by the way, here's your response. Thank you for long polling, right? Because the database the backend, after the response is ready, it will write it back to the queue and says, all right, this is the ready queue, this is the submission queue, just like IO Ring, right? How it does it, very similar. So you submit it to the submission queue, this is the receive queue or the ready queue, and then it says, all right, you just consume it. So if someone queried something, it says, all right, check, is it in the queue, in the receive queue? Yeah, yep, it's there. If it's not there, continue long polling, right? Very clever. And you can just resume this. So this is one of the, the perks. So even if your application crashed in the client side, you came back, you can even save that UUID, that job ID that the server gave you in the client local storage or on disk or on file. And you come back and says, oh, I had a pending job. Here's my job. And you can just ask the server back, right? Is this thing ready? You might say, well, it is ready. Here it is. Well, no, actually, you know what? I'm not keeping your stinking jobs there forever. Because that's something you have to keep in mind, right? You cannot just submit 1,000 jobs and keep them on the queue and the response forever. You gotta be realistic for that. So you set an expiry date for those responses, and you can just delete them after a while, or even have the database do that. I think Redis have this capability, right? Expiry, and it will just disappear after a while. So these are what I wanted to talk about. Long polling. So summary, what did we discuss? We discussed this ability of polling, right, in the backend, i.e., there is a piece of information that I want to know if it's there or not. And I'm not sure if it's there or not. So I'm going to poll. I'm going to ask the backend to see if this piece of information is there. An unread message, an uploaded video, a log file, anything that is it ready there or not? No? So traditionally, we always used the polling method. Is it there? Is it there? Are we there yet? Are we there yet? Are we there yet? Are we there yet? The problem with this approach is its chattiness, right? And it's resource intensive for the backend. And we want to keep our backend as happy as possible, as unbothered as possible. One client might not do much damage with this chattiness, but 1,000, well, especially people keep browsers open with many tabs. And if every tab's doing this unnecessary polling, it adds up, right? Okay, so that's the polling. So then a long polling came into the picture and says, all right, let's minimize this and say, I'm sending a request to poll, but tell me only when there is something. Don't tell me if there is nothing. I don't care. Right? Just tell me when there is something. And then this is also tunable, like saying, hey, tell me if there is something and only have me wait for 10 seconds, right? If there is nothing for 10 seconds, just tell me there's nothing. Something like that. So this also further minimizes the chattiness, but you can still continue the polling, but still keep the pipe alive, as they say. You can still make the request. Then something to watch out with long polling is timeouts, of course, especially if you have mailboxes, Nginx, HA proxy, any layer 7 proxy that actively reads your messages or requests, and it's actually sniffing and waiting for a response from the backend. It might actually just terminate, and it will give you a 504 gateway timeout. So say, gateway timeout. I waited for this response and it never came back. This might have. You've seen this error before, right? Although the client doesn't mind waiting, proxies might, and that's something you have to watch out for. What else? Then we talk it even further and says, okay, how about you can technically turn any request response normal, a submission, an actual request, not to poll, but to actually execute something. Something that is more expensive, actually, which makes sense, like, hey, generate a report, generate a summary for me. Things that are Backend, both CPU and IO intensive and time consuming, a minute, 3 minutes, 5 minutes, 6 minute job. But you can turn that into from unpredictable, unscalable system into a predictable, efficient system, and by essentially introducing a queue, like you submit a request, but instead of actually processing the request directly, put that request as a message in a queue, and then have a pool of processes or threads, if you're fancy, and have them pull with a U from the queue to actually execute those requests, and then write back to maybe to another queue that, hey, this is ready, right? After you do that, you can submit back a response immediately to the client saying, hey, I received your request, here is an ID. It's like a ticket. Go, come back and tell me whenever, I'll tell you whenever this is ready, right? So the client come back with a long poll request saying, hey, this is my ticket. It's a UID or it's an ID, whatever you end up using. It's probably best to use UID v7 or ULIDs for these kind of things. If you decided to use UID at all, never 4, because those, if you are storing this in a database, checking in a timely manner, having them sorted and checked is always better, because we know we're gonna hit the tail end of things, because we're inserting all these things, they go all at the end, and people often query at the end. When you query jobs, you never query jobs that from 7 months, right? You always query the latest one. So just that's a side thing. But yeah, you're gonna get back a UID, and then you come back and with a long poll request. So we turned a normal request that is unpredictable and scalable into a predictable, scalable system, and DDoS free, from the long poll request, right? And these clients will come back with these long poll requests, and then they can check their status, right? And of course, you have to put limits on these messages such that you cannot just generate responses and just leave them there forever. You have to put expiry dates. And that's what building systems about. It's just about having fun and fireworks everywhere, and you break things, and you enjoy doing this, and then you make mistakes here and there, and then you just see the fireworks of it all. And that's what all about software engineering. Yeah, I just thought I'll talk about this stuff. Look, boy, I can't believe I talked this into an hour. What is it? What I've been recording to? I wish OBS will tell me how long I've been recorded to. God dang it. Yeah, actually, 35 minutes. Yeah, I can't believe I talked 35 minutes about this stuff. I love this stuff. I could go for a longer time even. I didn't even talk about push. Push here is really interesting. When it comes to the things, it can spice things up. Yeah. What do you think about all this stuff, guys? Have you used long polling in your system? Let me know in the comment section below this. Guys, see you in the next one. Goodbye.